title of this note is Gaussian Elimination, and the outcome is that you're going to be able to solve a system of equations with 3 or more variables using a technique called Gaussian Elimination. So in Gaussian elimination, your goal is to take your matrix and to convert it into what is called row echelon form. Row echelon form means that your matrix has only ones along the main diagonal, and every number below the main diagonal is a 0. Now the numbers above the main diagonal, they can be any number. I'm going to put stars there to represent any number. And the last column, those values can also be any number. What we're interested in is the main diagonal needs to be all ones, and every value below the main diagonal needs to be zeros. So how do we do this? We are going to use our row operations. So the steps are, in step 1, first you're going to write an augmented matrix. We've been practicing that with our word problems. Step 2 is you're going to get your matrix into row echelon form, and I'm going to show you how to do that on the next page. Once you're in row echelon form, you still have not solved your system. What you have done is you have solved for one of the variables. So what you now have is a new system where one of the variables is solved. That's step 3. So you're going to write a new system, and I'm going to add the word new in here. Write the new system of linear equations, and then you're going to use a technique called back substitution to solve for all the variables. So by the end of this, you'll have a solution, x, y, and z. So a couple of hints when you're doing Gaussian elimination. You want to work down the staircase. So that means if you have a matrix, you have values here. I'm just going to put letters for each element. Down the staircase means that first you work with A, and then you work everything below the A. So then you'll work the D and the G. And then you're going to go down the stairs, and you'll work with E and everything below it. And then finally you'll work with J. Remember that you want ones in the main diagonal. So whenever you're trying to get a 1, you probably want to use the multiplication row operation. And if you're trying to get a 0, adding will typically get you there. So let's look on the next slide how we're actually going to do this. So I'm going to do with you an example from the book. This is on page 805, example 5, if you'd like to follow along with the book. So the example gives us a system, and it's just a 2-variable system. The technique will be the same in a system. It's just going to have more steps. So our first step is to convert this into an augmented matrix. So I have to have my x's lined up. That's the first column, and my y's are the second column. Remember, you're going to use that line for the equal sign. So there's the augmented matrix. Now I'm going to work down the staircase. So I'm starting in this top left element, and I want that to be the number 1. You want to do as little work as possible. I notice that the next row starts with the number 1. I really want that to be the first element. I can do that by switching the rows. So my first row operation is to switch row 1 and row 2. You do have to write down what you are doing, and then you're going to do it. All right, so I've got the top element as a 1. That's perfect. That's exactly what I want there. Now I'm going to move down the staircase. So I'm going to work on this 2. I really want this 2 to be a 0. I'm going to add something to it. What do I add to 2 to be 0? I hope you see that I want this to be a negative 2. The negative 2 that I want has to come from the same column. So Here's 2. I want to add negative 2. So the only other place I can go is here. How can I make that a negative 2? I can make that a negative 2 if I multiply that by 2. So my 2 is coming out of row 2. And the way I'm going to get a negative 2 is I'm going to multiply row 1 by negative 2. That'll get me 0. So this is the operation that I'm going to do. And I'm going to put the answer in row 2. So the first row is not changing. And I'm going to complete this operation, row 2 minus 2r1. And I'm going to complete it for every column. So here I have 2 minus 2 1s is 0. 1 minus 2 3s is negative 5. And negative 8 minus 2 6s, if you want to work that out, that's going to be negative 20. So I've got my first column. Remember, I'm working down the staircase. I've got the 1, I've got the 0. So now I'm going to step down the main diagonal, and I'm going to work on that negative 5. I need that negative 5 to be a 1, so that I have all 1s on my main diagonal. Remember the hint, when you're trying to get a 1, multiplication is the way to go. If I want to turn a negative 5 into a 1, I could just divide by negative 5. That's the same thing as multiplying by the fraction. So I'm going to take everything in row 2 and divide it by negative 5. So row 1's not going to change. 0 divided by negative 5, negative 5 divided by negative 5, negative 20 divided by negative 5. So now this is in row echelon form. You'll see this abbreviated a lot, REF, row echelon form. I've got 1s along the main diagonal, and I've got 0s below it. I don't really care what's above it. That's not interesting to me. So what this has done for us, it has helped us get closer to solving the system. Just like how we started, how we took the system and wrote it as a matrix, now we can go the other way. Here's a matrix. Let's rewrite it as a system. So this system would be x plus 3y equals 6. And there is no x term in the second row, so it's just y equals 4. What's really cool about Gaussian is that you'll always have one variable solved for. How convenient. Now we know what y equals. So now we're going to use a technique called back substitution. Back just means that we're going to go back up a row, and we're going to substitute 4. And we're just doing very basic algebra to get that x equals negative 6. So the solution is an ordered pair. You can either write it as x equals negative 6, y equals 4, or you can write it as the ordered pair, negative 6, 4. Both of those are acceptable. So that's it for these notes. Go ahead and draw a line, and then we're going to practice this in class.